Welcome to the EERE satellite, a new innovative remote sensing method for identifying and monitoring plastic pollution in the ocean. The main objective of the EERE satellite is to understand global and local ocean surface currents and dynamics. This knowledge will then be incorporated into monitoring global marine plastic debris concentration and distributing movement patterns. Ocean currents are complex and highly dynamic, and therefore need to be monitored constantly. Plastic will be moving within the major ocean currents, and therefore an understanding of currents along with a sensor to identify plastics will allow plastic to be identified, tracked and mitigated. EERE mission satellite is based upon the HY2 series satellite run by the National Satellite Ocean Application Service. This satellite is a marine dynamic environmental satellite used to measure ocean surface temperature, wind fields, wave and topography currents. In order to measure these parameters, the instruments, the RAD microwave radiometer, ALT radar altimeter and scatometer. Also added to this satellite are instruments to measure plastic particulate pollution concentrations. Using previous techniques with the moderate resolution imaging spectroradiometer instrument to measure reflectance differences between plastic particulates and the surrounding ocean waters. Imaging these multispectral measurements in the visible to infrared waveband range, as this is where the differences in reflectance is best seen. Detection of plastic polymers via wavelength signatures that contrast to seawater determine the presence and concentration of plastics. These signatures are unique to main types of plastic marine debris. This instrument will help to track the changes in ocean over time.
Currently, the method to observe plastic in the oceans is through airborne measurements. No satellites or remote sensing means have been developed yet. However, this is the best method in which to have near real-time observations of global plastic concentration and movement in the oceans. Satellite imagery could be a huge innovation towards helping both science and society. Remote sensing and the use of satellites is the only technology that is able to provide uniform observation coverage of large areas of the oceans and shorelines, which airborne technology is not able to do. Measuring global plastic concentration and movement is important. Currently, more than 50 million tonnes of plastic is in the oceans, and this is expected to triple over the next decade. Much of this plastic will arrive to areas which are inaccessible and only be able to be identified and hence mitigated by the use of satellites. The durability of plastics results in a slow breakdown process which releases toxic chemicals into the oceans and as a consequence harming marine life and other water sources feeding into oceans. Measuring global plastic concentration as a function of understanding ocean currents is important due to the movement of plastic being controlled by these currents and dynamics. Measuring plastic concentration alone would not be sufficient enough in order to try and globally control our exponentially growing usage and waste of plastics. Having a strong knowledge of plastic hotspots and their mobility will enable governments and global organizations to prioritize particular impacts of marine plastics and to monitor the efficiency of the measures currently taken to combat the global ocean plastic pollution crisis.
Plastic pollution in the oceans is an urgent pollution parameter and scientific challenge which needs to be addressed in Earth observation in a changing world. ESA have stated themselves that advances in technical capabilities are necessary in order to respond to the ever-increasing social needs associated with the risks and opportunities in our changing global environment and climate alongside the continual population growth. 4.8 to 12.7 million metric tons of plastic dumped into the sea every year. Marine monitoring of plastics would allow for more accurate estimations of how much plastic we are adding to the oceans each year and the locations where lots of plastic is being injected into the oceans. Where most of the plastic is accumulating can also be determined. Floating plastic near or at the sea surface is exposed to very complex air-to-sea interactions, and so the dynamics are not fully understood. However, a monitoring or tracking system would greatly improve the understanding of these interactions. The accumulation of microplastics, that is, plastics under 5 millimeters in diameter, is of great concern due to the toxicity of them. The NOAA Marine Debris Programme is leading efforts within NOAA to research this topic. Microplastics come from a variety of sources, including from larger plastic debris that degrade into smaller and smaller pieces. In addition, microbeads, a type of microplastic that are very tiny pieces of manufactured polyethylene plastic that are added as exfoliants to health and beauty products, such as some cleaners and toothpastes. These tiny particles easily pass through the water filtration system and end up in the ocean and Great Lakes, posing potential threat to aquatic life. It is also important to understand and have data on ocean current movements out with plastics, because they work to understand the role of oceans in the Earth system and how they affect our climate. Measurements of ocean surface currents are fundamental to a number of practical applications, such as marine search and rescue and emergency response, ship routing, and anthropogenic and natural pollution, and offshore renewable energy monitoring. Ocean currents are complex and highly dynamic, and therefore need to be monitored constantly on a global scale.
This mission fits with all NASA, UN, and ESA priorities. Satellites play a major role in furthering our knowledge and understanding of the planet. ESA aims for their missions to allow us to respond better to the changing environment and climate. The main goal is to challenge ESA and the scientific communities to further the technology available at the moment so that they can effectively respond to the changing global environment. The proposed mission would play a role in this, as it aims to be able to map the marine plastic, which is a huge environmental issue. If it is able to be mapped, then it can be dealt with more effectively. The key messages for ESA's science strategy are to create an integrated Earth observation system for effective use of resource while avoiding data gaps. It should engage the public in the research and mission and have an open data policy with easy access to the data. The mission should continue current innovations and must benefit both science and society. The proposed mission concept science question also addresses societal issues such as food security and available fresh water alongside the overall health of the planet and mankind. It fits with a number of UN sustainability goals, number 3, number 6, and number 13 and 14.
The HY2B satellite is expected to run from 2018 to 2020. EERE mission will be expected to last longer than this. We aim for this satellite to remain in orbit for a minimum of 5 years with potential for extension. Hopefully, this will establish the importance of this issue being investigated, and other satellite programs will then follow. HY2B was 1,500 kilograms at launch date, meaning that it cost roughly £60 million. However, our mission is also going to include the same instruments, but also adding imaging spectroscopy through the MODIS instrument. Therefore, the payload will be greater and hence an increase in the cost of the mission. For the satellite orbit, we've chosen a sun-synchronous orbit. This orbit has been chosen because there will always be a constant surface illumination angle, therefore reflectance differences between plastic particulates and the surrounding ocean waters will be different. Choosing a geostationary orbit, for example, would not work for this mission, as this mission aims to monitor global ocean currents and plastic distribution. This satellite altitude will be similar to that of the HY2 satellite series, roughly at 960 kilometers.
The key criteria of the mission are to monitor global marine plastic debris concentration and distribution and movement patterns. It will also help to understand global and local ocean surface currents and dynamics, so that the areas where plastic and debris are collected can be identified and dealt with. The mission also needs to remain environmentally sensitive and considerate, whilst producing relevant and accessible data that can be used for the advancement of society in line with the UN Sustainable Development Goals. The data collected will give us an ocean-wide view of plastic distribution, combined with knowledge of surface circulation patterns, allowing a spatial analysis of plastic distributions. Post-collection and analysis, the data can be used to identify areas where plastic has accumulated, and these areas can be targeted in order that they might be cleaned. The orbital cycle of the satellite will be approximately 27 days. This will mean that an evaluation of the changes that have taken place in the same geographical location can be made once every 27 days. This will be the limiting factor in how quickly the data can be collected.
The proposed mission aims to understand global and local ocean surface currents and dynamics, which can then be used to help monitor global marine plastic debris concentrations and distributions. Using satellites allows this to be monitored constantly, which gives us a better understanding of how they work. Using a marine dynamic environment satellite to measure ocean surface temperature, wind field, wave and topography/currents through microwave radiometers, radar altimeters, and scatterometers will give a broad overview of the ocean currents in relation to marine plastics. With the addition of instruments to measure plastic particulate pollution concentration, the marine plastic can be mapped and changes can be tracked over time. These observations are currently made by airborne measurements, which are not as effective as satellites to gain near real-time observations of global plastic concentration and movement. This satellite will help to solve both societal and environmental issues in a way that has not been done before. As plastics are a huge problem in the ocean environmentally, it is extremely important that they are observed on a regular basis to avoid further environmental damage.